Hi, okay, see you again in the lecture number 3, my video number 3 for mth3103. So in this video I'll talk on the dot product and cosine formula, direction angle, and I will end up with some application. Okay, so right, first thing we go to the dot product and its properties. Dot product, also known as a scalar product or inner product, also known as scalar product or inner product. So let me give the definition for the dot product of two vectors. Definition: if we have a vector A with components A1, A2, A3, and you can expand it to up to n if you want. So B with components B1, B2, B3, then A dot B we define as A1, B1 plus A2, B2 plus A3, B3, or you can also write this as a summation of AI, BI for I1 to 3. If you consider in n dimension, of course you can expand it up to n elements. There's n element, then we can add up to n elements. So basically A and B are two vectors, and the dot product yield the scalar. Okay, for example, again the example is pretty simple. If we dot two vectors -1, 7 and 4, dot 6, 2 and -half. So you have here -1 times 6 plus 7 times 2 plus 4 times -half. Right. So that gives you -6, 40 minus 8, so you have -2, so you have 6, right? 6. So this is a scalar. Scalar means it's not a vector. Now let us talk on the properties of the dot product. Properties of dot product. If A, B, C are vectors, and alpha n is scalar, then we have one A dot A, that gives you magnitude of A squared, 2 A dot B, this is equal to B dot A, and 3 A dot B plus C, this is A dot B plus A dot C, and for alpha A, dot b, this is equal to alpha a dot b also equal to a dot alpha b. And 5, we have a 0 dot a, that gives you 0, and 6 a dot b, magnitude of a dot b, it will be less than a magnitude b. Again, for the proof, I think this is not that difficult. You can always consider a with components a1, a2, a3, and b with component b1, b2, b3, and c with c1, c2, c3. Okay, so if you, let's say, I just show you the simplest one, a dot b. If you want to show a dot b by definition, so this is, we have a1 b1 plus a2 b2 plus a3 b3. So you can, because this is just a real number, so you can change the order of those. So we have b1 a1 plus b2 a2 plus b3 a3. So this is actually b1 b2 b3 dot a1 a2 a3. That gives you vector b dot vector a. So let's look at the cosine law. We have a theorem. If theta is the angle between vector A and B, then A dot B, this is equal to magnitude of A, magnitude of B cos theta. Now, how to prove this? Or you can visualize this. So if you have, let's say this is your vector A, this is your vector B, so the angle theta is here. Okay, so theta is the angle between A and B. So if you want to prove this, so you may consider, let's say this is a point 0, P and Q here, and this vector is given as A minus B. Okay, then we can use the law of cosinus law, from the cosinus law. So we have A minus B squared, this is equal to A squared plus B squared minus 2A B cos theta. Yeah, you want to find that the length of that is given as the length of this squared plus that squared minus 2 times the length of AB and then cos of that theta. So this is the cosinus law. Now from the left hand side, which is this part here. So we have a minus b squared. So you can write this using the definition of magnitude of vectors. The properties, one of the properties in the dot product. So we have this is a minus b dot a minus b, right? If you can expand that, so here we have a dot a minus a dot b minus b dot a plus b dot b. So this is not cancel out. Alright, so we have that by definition we have magnitude of a squared. This one is 2 minus 2a dot b, and that one is plus magnitude of b squared. Okay, so we have, so a squared plus b squared is minus a2 minus magnitude of a magnitude of b cos theta. So you can bring out those things. So we have minus 2a dot b. This is equal to minus 2a b cos theta. So not difficult for you to see those things, right? Okay, just equate to the right hand side, because this equal to we have a squared plus b squared minus 2a b cos theta. This is from the right hand side, of the cosinus law. So what left is that one is cancelled out with that cancel out with that. So we left is negative 2a dot b is equal to that. Okay, so therefore we have a dot b is equal to a b cos theta. And again, if you are given a vector a and b, so we can find, so from there we can find, so therefore we can find the angle between vector a and b, which is given as cos theta is equal to a dot b over a b, and then you can find theta. Of course, here theta is inverse cos a b magnitude of a magnitude of b. So you can see from this theorem that yeah, if theta is, if you have if theta is pi over 2, which means a are perpendicular to b. Yeah, so we have, let's say this is vector a, this is vector b, is perpendicular, that case. So for that case we have, if you substitute theta pi over 2 into the theorem, theta pi over 2 is 0. So what we have is a dot b is equal to 0. So what we have, a dot b that equal to 0. So which means if you want to show that two vectors, yeah, I make a note here, if you want to show that two vectors are perpendiculars, then we need to show that A dot B must equal to 0. Okay. Now let's see the direction angle. Let's see the direction angle. I think in my first video I have explained to you what is the direction angle for the vector in space or in three-dimensional case. So for vector in 3 dimension, so we have x, y, and z. Let's say this is your vector. Let's call this your vector A with component A1, A2, A3, and this is the angle between vector and x-axis, which is alpha, between vector and y-axis, so this is, let's call this as a beta, and z-axis, let's call this is gamma. Okay, so from here we have cos alpha. This is given as A1 over magnitude of A. Cos beta is equal to A2 over magnitude of A, and cos gamma is given as A3 over magnitude of A. We have some exercise, if I'm not mistaken, that I have given to you, so hopefully you can solve those exercises. So give you an example. Okay, find the direction angle. Find the direction angle of a vector A given as 1, 2, 3. Okay, so what you need to find here is you need to find what is alpha, beta, and gamma, 3 of them. So we use those formula. So cos alpha is given, we can find that this is 1 over square root of magnitude of A is, what is magnitude of A? Magnitude of A is, so 1 plus 4 plus 9, right? So we have 10, 14, so this is square root 14. So cos theta is 1 over square root 14, cos beta, this is 2 over square root 14, and cos gamma, this is 3 over square root 14. Okay, and therefore you can find what is alpha, which is, I put that 74 degree, and beta 58 degree, and gamma, you can use your calculator here, 37 degree. Okay, now let me give you the example of application. Application example: a 100 kilogram weight hangs from two wires. Find the tension of forces T1 and T2 and their magnitude Okay, so let's say we have a flex like that, and then we have two wires. Alright, this make 32 degree, this make 50 degree. Okay, and we have, this is our weight, 100 kg, that. Okay, so let's call this W. Then tension, so this is our tension, that is T2, that is T1, that's T1. Okay, and from those it is obvious that the opposite angle here, this is 32 degree and this is 50 degree. Now, how to determine the vector T1, T2? Yeah, how to determine vector T1, T2? So you always can consider that this is on x-axis, all right, and this is for y-axis. So you can always find the vector there, and you can always find the vector those y. So as well as for T1, you can find the vector for x-axis and for y-axis. So for T1, so what we have here for T1, so this is the negative of I. I is positive. I positive is right side. This is goes to negative left side, so it's negative. So this is a negative of magnitude T1 cos 50I plus T1 sine of 50 J. Okay, just use a trigonometry rule. Use a trigonometry rule. So we have x and y. So remember that if you have a vector, you have a vector here, add up with that, so this is the vector that we are looking for. So in this case, this is our, for this case we have, this is our T2. You can do a similar thing for the T1, and you can find here, this is with this angle, that's a theta, so the length there is given as magnitude of T2 times sine theta. So here for that we have magnitude of T2 cos theta. Yeah, so you just add up those two vectors to make it vector. This is in I direction, so we need I. To make this vector, then we need J. So add up those two vectors, so that's what we have. Okay, so you can do for T2, so we have, this is T2 cos 32I plus magnitude of T2 sine 32J. And T1, T2, you add up this T1, T2, you have that direction, but opposite of those, we have negative of that vector. So we have T1 plus T2, that give you minus W. This is 100 in the direction of J. Then you can apply this where you have T1, T2 is given here. You just plug in there. So what we have, therefore we have minus T1 cos 50i plus magnitude of T1 sin 50j plus T2 cos 32i plus T2 sin 32j, that equal to 100j. Use that relation. So if you equating the components, we equate the components. What we have, the vector component for I equal to component for I right hand side, component for j left hand side equal to component for j for the right hand side. So what we have, T1 cos 50 plus T2 cos 32, that equal to 0, and you have T1 sin 50 plus T2 sin 32, that equal to 0. So we need to solve these two equations for T1, T2. Okay, solve for magnitude of T1 and magnitude of T2. You have two equations with two unknown. Of course, you can solve this. Okay, so what you can do, let's say if I give name here, this is, let's say that's equal 1, equation 1, that's equation 2. You can multiply equation 1 with sin 50, and multiply equation 2 with cos 50. Then you can, from there you can find T2. You can find T2. As well as if you want to find T1, you multiply that first equation with sin 32, multiply second equation with cos 32. So subtract those things. Missing something negative here, should be. Okay, so you can find. So with this we can find T1 is equal to 100 over sin 50 plus tangent 32 cos 50. That's more or less 85.64, and T2, this is 64.91. So therefore our T1 is negative 55. What is 55? I think this is try to find out this. Just use your calculator. So you have, this is for T1, then you can just substitute there, and cos 50 you have there. Okay, substitute, you have T with that and T2 with that, and evaluate those things. So what you have, T1 is minus 55.05i plus 65.60j, and T2 is 55.5i plus 34.40j. So that's the solution. We find the magnitude of T1, we find the magnitude of T2, and also we find the vector T1, T2. Alright, let me end up with this video with some exercise for you to try. Okay, prove that cos law. So we have c squared equal to a squared plus b squared minus 2ab cos theta. So this is magnitude, this is magnitude of vector A. Oh no, sorry, I don't want to use that. So this is just AB. Okay, and then in order to show this, I think you can consider the C as a magnitude of vector C, so you can solve this thing. So in order to prove this, you consider this vector AB. This is let's say angle theta, then this is your vector C. Okay, from there of course you can have A is equal to B plus C. You can find C is equal to A minus B. Okay, and then your dot product C and C, this is equal to A minus B dot A minus B, and then you can solve this. I leave you those things, you continue with that. Okay, and one more exercise, number 2. Prove that the diagonal of a rhombus are perpendicular. So rhombus is like a kite. This is rhombus. So the diagonal, if you connect those two diagonal, so they are perpendicular. Okay, so you may consider this point P, O, P, Q, R, right? With this vector A, this vector B, and then you proceed the rest. Okay, so with those two exercises, so and let me conclude a little bit. I have explained in this video that give you the definition of dot product. I prove or give the formula or theorem for the cos, for the angle, alright, and also some application, and as well as the properties of the dot product of a vector. Okay, so with that I thank you. So we stop here. Thank you.